question 7. In question 7, the purpose is to examine a linear relationship between two numerical data sets. Similar to what we did in our previous question, where we in fact compare the relationship between two categorical data, in question 7, we'll be doing the same, but this time exploring the relationship between two numerical data sets. As you can see, the number of customers here are in numerical form, same as with our sales revenue. So a regression analysis is usually used to analyze a linear relationship between two numerical data sets. And to do this, we are being asked to perform series of analysis by finding the coefficient of determination, by creating a scatter plot and a trend line, providing an interpretation for the y-intercept as well as the slope of the regression line, and by performing a prediction based on an x value. So in order to do this, we go to data analysis, and select regression. Click OK. Take this, clear all the stuff in which I previously used. So the dialog box for regression will ask for two input range. The first is the input range for y. So that means we need to select the y variables. And the y variables represent the independent variables. So in the question, I stated which one represent the independent variables and which one represent the dependent variables. The number of customers is your independent variable, which is the x, whereas the monthly sales revenue represent your y, which is your dependent variable. Obviously, your sales will depend on the number of customers you have. So in that regard, your sales becomes the dependent variable denoted by y, whereas your number of customers represent your independent variable, which represent your x. So in that case, we're going to select our independent variable and our dependent variable into the corresponding input range. So for the input y range, we select the monthly sales revenue, the data set for the monthly sales revenue. You note that I've included the column header in my selection. For the x, or for the independent variable, I'm going to select the x values in the input x range. Now I'm going to click on labels to indicate that the first row of information are labels, so Excel should not include them as part of my data values. And then lastly, I'll click on the input range to indicate where I would like to display my results. So I'm selecting a blank cell right here to indicate so. Click OK. And here we go. We have a lot of information, but I'm going to highlight the needed one for these questions. So first, we've been asked to find and interpret the coefficient of determination. Your R square represents the coefficient of determination. So in this example, the value is 0.4809. And usually coefficient of determination are written in decimal form, and in order to make the interpretation more meaningful, we tend to change it into a percentage, which then becomes 48.09%. And what that means is 48.09% of your dependent variable is determined by the independent variable. So 48.09% of y is determined by x. So to have a proper narrative, I will have it as 48.09%. So here we go. 48.09% of sales revenue is determined by the number of customers. Right? So that is what essentially coefficient of determination represent. What percentage of your y is determined by your x? Right? What percentage of your dependent variable is determined by your independent variable? Now the B part, I'll skip that and go to the Y. The C part. The C part asks for interpret the y-intercept. The y-intercept is given by this. It should have the intercept, which is given as 21,613.14. So what that means is, what is y when x is 0? What is y when x is 0? So that is the question that the y-intercept addresses. So in this case, when the number of customers is 0, we expect sales revenue to be we expect sales revenue to be 21,613.14. Right, so that is the starting point. That is the starting point of your regression slope. So it measures when x is 0, what the y should be. Your regression, the slope is given by this value right here. It's given by the value 709.29. So what does that mean? It means when x increase by 1 unit, how much change is expected in y. When x increases by 1 unit, how much change is expected in y? In this case, we say that when the number of customers increase by 1, we expect sales revenue to increase by you notice that the slope is a positive number. The slope is a positive number. As a result, we expect sales to increase. Suppose the slope happens to be a negative number, then we expect our y to respond by decreasing. So a negative slope, it means an increase in x will lead to a decrease in y. However, a positive slope means an increase in x will lead to an increase in y. So take note of that. I believe some of you might have some negative for the slopes, and if that happens, then that's the interpretation. An increase in x will lead to a decrease in y by that much. And the last part of the question asks you to predict the monthly sales revenue for a staff with 80 customers. So we're going to do this prediction by using the regression equation, which is y plus b times x, right? The y plus equals to a plus b times x. The a represent the alpha, which is represented by the y-intercept. The b is the slope, which is given by the slope of the regression line. So if I have to rewrite these formulas, given the data or the values I have, then this should be written as 2,1 as this. So that is the y-intercept. This represents the slope, and the x is the value. It takes on the value that we want to predict, that the prediction is going to be based on. Our prediction is we want to predict the monthly sales revenue for a staff with 80 customers. So this number, the x becomes 80. In that case, our solution to our equation will be so take note, you do the multiplication first before you do your addition second, right? So that means a staff with 80 customers is expected to make a sales revenue of $78,356.34. Now back to question B. For question B, we need to construct a scatter plot and a trend line and display the regression equation on the chart. So in order to do this, we're going to select entire data set and go to insert, and we're going to insert a scatter plot, right? And I believe we did that in our previous assignment. We click on scatter plot and pick the first one. Okay. And just let's position that nicely somewhere. So that's our scatter plot. As you can see, the scatter plot indicates a positive trending. It's in a positive relationship between sales and customers. The more customers you have, the more sales you make, a staff will make. So in order to show this trend line, just right mouse click on any of the dots and select trend, add trend line. And then this dialog box will appear, and go down, scroll down and click on display equation on the chart. Make sure that is checked and close that dialog box. And here you go. The equation is basically plotted on the trend line, and these are the numbers that we had right here. 709.29x, which in this case 80 is our x, and our intercept is 21613, which is 21613. This equation here just brought the slope first and then brought intercept second, which is similar to this, but it just flipped. This one, the intercept is written first plus the slope and then the x, but in both instances you end up with the same results. So this is essentially what question 7 requires you to do. It requires you to do a regression analysis and find and interpret the coefficient of determination. It also helps you to come out with the scatter plot and the trend line and the regression equation. You're able to provide interpretation to the y-intercept and the interpretation for the regression line, and then perform a prediction based on a value of x. Now this is something extra I just want you to take a look at, and it's just something we'll be covering in class though, right? If this is the y-intercept, the lower the intervals between the y-intercept, the 95% interval range for the y-intercept will be, you know what, I would just ignore this at this point.